And welcome everybody to the daily space weather. We're looking at two sunspot groups here. Sunspot 2824 under my pointer. Sunspot 2826 with its odd ring-shaped orientation. And the fields are at a 90-degree angle to the way we normally see them. Normally, the opposite polarity fields are east and west of each other. This time they're north and south of each other. So it's an interesting sunspot worth keeping an eye on. And when I say eye on, the pun's intentional. Let's take a look at the coronal mass ejections that just occurred, as we've seen some more happen. So let's take a view from Lagrange point 5 and Lagrange point 1. We're going to show you two views here from stereo A and from the LASCO C3. So this latest coronal mass ejection here is expected to miss the Earth to the west. So on the left you can see stereo A. That spacecraft is located at Lagrangian point 5, the gravitational equilibrium point that trails the Earth orbitally. And on the right side, this blue imagery here, that's the LASCO C3, part of the SOHO spacecraft, located at Lagrange point 1. So you're looking at this coronal mass ejection from two separate angles here, one from in between the Earth and the Sun, and one from behind the Earth. Stereo A sees space weather before the Earth does, hence it's called stereo A for ahead. Anyway, again, these are expected to miss the Earth, and the coronal mass ejections expected to arrive yesterday are a little bit late, indicating that they were moving a little more slowly than perhaps estimated. NOAA forecasts include geomagnetic storm conditions into early tomorrow. So this is still consistent with the idea that it would take about 36 hours for the full extent of the Earth-striking coronal mass ejections to arrive at the Earth geomagnetic space. We just showed you a close-up of those sunspots in 304 angstroms. Here's a full disk view. And the coronal mass ejection that we just saw is from this filament up here. Again, expecting that one to completely miss the Earth. Here's another close-up of sunspots 2824 and 2826. And you can see the formation there of 2826. That, especially 2826, has significant potential to produce large solar flares. Don't be surprised to see additional significant solar activity coming out of that sunspot, sunspot 2826. Great view of the ramping up of that sunspot's complexity. Here's a diagram of the solar system, and we've got a total lunar eclipse about to happen in places like Eastern Australia. We'll get to it. And there's where things will be in a week in the solar system. And total lunar eclipses only happen during a full moon, folks. Happy full moon. So here's the star chart. We put this up regularly. And if you're up before dawn where I'm located, you might see the moon and Saturn and Jupiter up there near the ecliptic, the path the sun takes across the sky. And the 10.7 centimeter radial flux, as forecasted, has jumped up to 84 solar flux units. And here's a one-year chart of that. The black line shown here is the 10.7 centimeter radial flux. The red line is the sunspot number. And those two are proportional sets of data. And you can see NOAA here forecasting geomagnetic storms into early tomorrow. So expecting geomagnetic unrest conditions, according to NOAA, here to end around 12 noon Universal Time tomorrow on May 27th. Let's take a look at global seismicity. Global seismicity, we're talking earthquakes. Here's the past 90 days in a convenient bar graph form, courtesy of volcanodiscovery.com. Here are the 5 magnitude quakes. And it looks like we saw 6 of those. And there are the 4 magnitude quakes, including one in Rwanda, actually. So some seismicity happening there. We'll get to that also. That was a 4.7 there in Central Africa. Very deep quake near Fiji at a 4.3 magnitude and over 570 kilometers depth. Chile saw a deep quake. So not a lot of crazy earthquake activity happening. Deep quake near Tonga as well. And also another one here only a half hour later in Western South America. Also Romania saw a deep quake. Please leave a comment if you're watching the video and you're a vampire. And there's another deep quake at Tonga. Mariana Islands also saw a deep quake. That was a 4.3 magnitude at 279 kilometers depth. Redwood Valley, California saw a quake 500 meters above sea level. And let's go into the realm of volcanoes, starting with the humanitarian crisis that's been created as a result of Nyiragongo, near the capital city Goma in the Democratic Republic of Congo. Death toll has climbed to 32, as Saturday night's eruption was pretty unexpected. A fissure opened, a lava lake drained, and fortunately that lava, which is very watery lava, stopped on the outskirts of town. However, the volcano is still erupting. So I'm just going to let the article scroll here. If you'd like to read, feel free to pause the video. Speed it up here a little bit as we don't want the video to be too long. There's a need for water down there, as people are fleeing the country, some into Rwanda. Let's see what else is erupting. Etna has been exploding. 12,000-foot ash plume over the Sicilian volcano. Suminosejima, 7,000-foot ash plume there. Great Sitkin volcano in the Aleutian Islands produced a short-lived explosion and a 15,000-foot plume of volcanic ash. Fuego exploding in Guatemala, 14,000-foot ash plume there. Sangay in Ecuador, 18,000-foot ash plume as it explodes. Revenador exploding as well, 15,000-foot ash plume there. Sabancaya were unable to detect. Please do not attempt to pole vault the caldera. Nevados de Chilean, intermittent emissions out of the central Chile volcano. And again, Nyiragongo, back to exploding and producing a 20,000-foot ash plume as the eruption continues to unfold in Congo. It's a reminder to not pole vault the caldera. Please don't pole vault the caldera. It could be unhealthful. This public service message brought to you by smAshomash.com. So we saw some C-class flares here happen in the past few hours, including one while we did show prep and one occurring as I record this portion of the video. There's the 3-day chart of the GOES X-ray flux. Those are solar flares. And remember, folks, solar flares are photons. Coronal mass ejections are protons. And we didn't really see any spikes in the proton flux. We'll be keeping an eye on that as geomagnetic storm conditions are still likely to arrive. Here's a 3-day chart of the GOES magnetometer, and this is going to start to look a little bit spiky and sawtoothed over the next day or so, as we've got an indecisive heliospheric current sheet. Here's a view of that. It's part of the Gong 2 data, which is part of the National Sunspot Observatory. And you can see there is a South Pole current sheet showing up here in red and then evaporating again. So we'll just have to wait and see what happens next with this one. Will we be in a South Pole current sheet tomorrow or a North Pole current sheet? The short answer is I don't know. And that's an important thing to understand in science, folks. Be brave enough to inform people that you do not know when you don't know. Don't come up with a ridiculous explanation of something that you don't understand. Just admit that you might not know something. It helps science to progress. So here's a line of sight ecliptic plane field plot. And you can see that indecision there over on the east side of the sun here. It's anybody's guess as to what polarity the Earth portion of the heliospheric current sheet will be when we make tomorrow's a daily space weather. Here's our line of sight coronal hole plot. It shows you the sun's B field in blue. You can see some North Pole oriented coronal holes there in red and some South Pole oriented coronal holes. North Pole oriented coronal holes in green and South Pole oriented coronal holes in red. Not a lot in the Earth facing zone right now. Next, detected sunspot groups and filaments. And there still are some filaments suspended between Earth and Sun. The likelihood of coronal mass ejections has gone down a little bit with the one that we showed you earlier in the video. Again, sunspot 2826 is interesting. You can see that its polarity is a little weird here. It's as if it's been turned 90 degrees. Normally we see the opposite polarities lining up in an east and west sort of a configuration. Here we can see them lining up in a north and south configuration. Sunspot 2826 could be interesting. We'll keep you posted. KP index now up to 2, having seen a pretty uneventful day yesterday. Again, as those coronal mass ejections must have been a little more slowly moving than everybody estimated. Next, the real-time solar wind. Looking pretty basic here. Not a lot of significant signals showing up here. We did recently see a shift in the phi angle. Besides that, solar wind density just under 11 protons per cubic centimeter, solar wind speed below 300 kilometers a second, so a very slow solar wind speed. Should be slow enough to show us any signals of coronal mass ejections striking the geospace. Here's a visualization of the geospace based on University of Michigan's space weather modeling framework. It should be 4 hours of data if all things are working properly. Again, the solar wind at a very low velocity here, below 300 kilometers per second, making for a rather low pressure environment around planet Earth. Next, looking at magnetic perturbations on the ground level. You're looking at changes to the Earth's B field now. And since we have a geomagnetic polar excursion going on, we show this data daily, 4 hours of data. If you want to see what was going on a previous day for the last about 3 years, go check out our previous daily space weather videos. Next, I wanted to also refer you to all of these Space Weather Prediction Center pages have a bunch of links down at the bottom. One of the links that you can find is this one that we're looking at here, the Geoelectric Field 1 Minute. So this will show you induction in the U.S. power grid. And this is something to watch if you're concerned about things like power outages caused by geomagnetic storms. And we are expecting to see this light up quite a bit when some solar ejecta arrives. This stayed largely calm yesterday. The geoelectric empirical data showing induction into the U.S. power grid. And there are a whole bunch of interesting links you can see down here. And this one is this one right here, Geoelectric Field Empirical EMTF 3D Model. And it's showing you millivolts per kilometer on that data set. Next, I'd like to remind our daily space weather viewers that today's cosmology segment video is going to be a separate video. We're going to do it entirely separately. Also, there will be a separate meteorology segment. We'll be streaming live to Twitch for that, and also posting it as separate videos on both YouTube and on BitChute. And we just completed our cosmology segment. Let's move on to the rest of the daily space weather video. Again, don't forget to check our playlists, folks. YouTube.com/Daily smAsho/playlists. And if you're viewing any place besides YouTube, most of our content is located there. So now we're looking at Van Allen belts. It's just a diagram of the Van Allen belts, folks, to prepare you for the next series of data sets. We're looking at electron flux. So electrons have the ability to charge up satellites, and we don't see any of that happening right now. We see moderate levels. Here is the 1-year chart of the greater than 2 mega electron volt electron fluence. And here's a 3-day chart. We did make it into warning levels yesterday. Our patrons would have already known that as we sent them an alert. And here's the electron forecast model. There are electrons out there, and we're interested in where they are as it gives us insight into the Earth's magnetic field environment. Here's a visualization of the total electron content. This is showing you the electron density for the entire air column, all the way from your GPS satellite down to your GPS handset, and the most likely spot of errors occurring. Next, we're going to show you the F ionosphere layer, and you see that red F over there on the right side to the right of where it says visible and infrared radiation. That F there is the F ionosphere layer located at about 300 kilometers of altitude. And this is actually a 2-day video of the ionosphere here, showing you 2 hours per second. And everything looking mostly normal here. Let me bring up the latest image. That's May 26th at 9:15 Universal Time. And let's do bonus features here on the daily space weather. I'm going to press refresh, and the latest data we can see here is from El Teide, Spain, the ground-based solar observatory. We actually saw a flare happen as we did the show. Let's see if we can see where it was coming from. I think the flare came from sunspot 2826, which is this one up here, the oddly oriented sunspot. And here comes some additional bonus features. Here's what we saw when we did show prep. And here's the latest imagery. I think that refreshed. I'll make sure it refreshed. And so this is a very interesting sunspot. Let me just show you the field configuration. So there's the field configuration. You can see this North Pole umbra right here. And this is South Pole. And that has the ability to produce significant solar flares. It looks like sunspot 2824 has continued to degrade here over the past 24, although this still does harbor the magnetic field complexity to produce significant solar flares. So on this one, we've got a South Pole field here, and these are both North Pole fields, as you can see on the colorized magnetogram. So that's about it, folks. Thanks for tuning in. Remember to stare at the sun, attempt to understand. Yeah, okay. Sorry about that. All right, so there's the El Teide, Spain imagery. Sometimes we forget to take down the test pattern, folks, and to get the videos out and publicly visible as quickly as possible, we don't typically edit them. So here's sunspot 2824 and sunspot 2826 and its odd field orientation. You can see the way the North Pole and South Pole fields are oriented north and south of each other instead of the normal configuration, east and west of each other, like sunspot 2824, a perfect example of the oddities between these sunspots. And here's some additional imagery for you. We've made a composite here. This is 1700 angstroms and 335 angstroms, just to sort of do something different. And we'll close things out here at 94 angstroms on a close-up. Again, expect to see geomagnetic storm conditions arrive despite yesterday's complete dud. Those CMEs must have just been moving at a slower speed, folks, as there were certainly some ejecta that was Earth-oriented. In any case, thanks again for tuning into the video. And may that solar wind be at your back